Hello friends, welcome to my channel Learn Computer Science and Application. Today in this lecture we will study foundation and introduction to data structure algorithms. Data structure में data are simple set of values or collection of data which can be stored in fields, records and files. In computer science, the mathematical model or logical model of a particular organization of data is called a data structure. There are two types of data structure. First is linear data structure. Linear data structure includes arrays, linked lists, tags, queues, and non-linear data structure includes trees, graphs, and heap. Operation performed on data structure include: first is traversing. Traversing means accessing each record exactly once. Second is searching. Find location of a given record in the data structure. Third is adding insertion. Adding new records to the data structure. Fourth is deleting. Removing records from the data structure. Fifth one is sorting. Arranging records in ascending or descending logical order. And sixth is merging. Combine two different data structure or files. Now we will study complexity of an algorithm. Algorithm is actually a well-defined steps for solving a particular problem. The complexity of an algorithm is the function which calculates the time complexity and space complexity of an input program. Time-space trade-off means if we increase the amount of space for storing the data, then the time needed for processing the data can be reduced and vice versa. Two criteria for measuring complexity of algorithm are: first is time complexity and second is space complexity. Space complexity is actually the amount of memory it needs to run the program to completion, and time complexity of an algorithm is the amount of CPU time it needs to run program to completion. Time complexity of an algorithm is actually the amount of CPU time or number of steps needed by program to complete its execution. The time complexity of an algorithm consists of two items. Number first is compilation time and second one is run time. Compile time. Compilation time is actually the time taken by CPU to compile an algorithm. While compiling, it checks for syntax and semantic errors present in the program and links them with standard libraries. Runtime is actually the time taken by CPU to execute the compiled programs. The runtime of an algorithm actually depends upon the number of instructions present in the algorithm or program. Time complexity can be classified into three types. First is worst case. Worst case is actually the longest time taken by CPU to execute the program, and it is denoted by big OS notation. Average case. Average case is the average time taken by CPU to execute the program, and it is denoted by omega notation. And third is best case. Best case is the shortest time taken by CPU to execute the program. It is denoted by theta notation. Standard analyzing techniques for calculating time complexity are: number first is constant time statement present in the program. Second is analyzing loops present in the program. Third is analyzing nested loop present in the program. Then analyzing sequence of statements present in the program, and last one is analyzing conditional statement present in the program. Here I have explained an example for calculating time complexity of a program. In this program, instructions 1 to 8 are executed only once, while instructions 3, 4, 5, 6, 7 are executed per iteration once, and there are n iterations present in the program. Therefore, the total time complexity of the program is 5n plus 3, as you can see in the example. Space complexity is the amount of memory or space required by CPU for execution of the program. In other words, you can say that space complexity of a program is the amount of memory consumed by the algorithm until it is completed. Types of space complexity. Type 1 space complexity is the fixed space required to store data and variables that are independent of the size of the programs. Examples include fixed memory required to store simple variables and constants. Type 2 space complexity is the space required by variables during runtime whose size depends on the size of the problem. For example, include dynamic memory allocation, recursion stack space, etc., which are allocated during runtime. Other type of space occupied are instruction space. Instruction space is the space in memory occupied by the compiled version of the program. Actually, this space is constant space or fixed size space for storing any value, suppose n. Data space. Data space is the space in memory which is used to hold the variable, data structure and memory allocated to data during runtime. This data space is related to the size of problem. Environmental space. Environmental space is the space in memory required during runtime to store function call using stacks. This is related to the runtime stack and hold the returning address of the previous function, stored return value and pointer on it. Here I have described different data types using different size of memory to get stored into the memory. First, data type bool, char, unsigned char, signed char, underscore int date require memory of size 1 byte to get stored into the memory. Similarly, underscore data type in underscore int16 short, unsigned short, wchar underscore t require memory of size 2 byte to get stored into the memory. Data type float underscore int32 int, unsigned int, long, unsigned long require memory of size 4 bytes to get stored into the memory. And lastly, data type double underscore int64 long double long require memory of size 8 bytes to get stored into the memory. Space complexity includes space to store program instructions into memory. Secondly, to store constant values into memory. Third, to store variable values into memory. And lastly, to store function calls and jumping statement, etc. using runtime stacks into the memory. Here in this example, I have written a program to compute space complexity of the program. In this example, I have written a program to find sum of n numbers in an array. In this example, space complexity depends upon the size of array, that is n, which is entered by user during runtime. Therefore, computed space complexity of the program is 4n plus 12. Here is in this example, I have written a program to find space complexity of the program. In this example, I have entered 3 numbers ABC. I have found their sum and the value is returned back to the user. Here the space complexity of the program turned out to be 20 bytes, as shown below. Here I have discussed a difference between time complexity and space complexity of a program. Time complexity calculates the time required to execute the program. Space complexity estimates the space or memory required to execute the program. In time complexity, time is counted for all statements. In space complexity, memory space is counted for all variables, inputs and outputs. And lastly, time complexity deals with computational time, change in computational time with the change in the size of the input. And space complexity deals with how much extra space would be required with a change in the input size. Time complexity of an algorithm is generally classified into 3 types. First is worst case time complexity, second is average case time complexity, and third is best case time complexity. Worst case time complexity is the longest time that is used by an algorithm over all instances of size n for a given problem to produce a desired result. Average case time complexity is the average time that the algorithm will use over the instances of size n for a given problem to produce a desired result. And lastly, the best case time complexity is the shortest time used by an algorithm over all instances of size n for a given problem to produce a desired result. Best case efficiency. Suppose we have a list of numbers 25, 31, 42, 71 and 105. Suppose we have to find the 25 number in the list. Here we can see 25 is present at the first position. Since only one single comparison has to be made to search the element, so we can say that C best efficiency is equal to 1. Average case efficiency. Suppose the element is not present in the first or the last location, but it is present somewhere in the middle of the list. So we have to find the probability of successful search, which will be equal to P, where P is greater than equal to 0 and less than equal to 1. Worst case efficiency. Suppose if we want to search an element which is present at the last of the list or not present at all, then such cases are called worst case efficiency. Suppose we have a list of numbers, say 25, 31, 42, 71, 105. Now suppose we want to find the number 105 in the list. Since 105 is present at the end of the list, so we have to make 5 comparisons to search the element. Therefore we can say that C worst is equal to n, which is equal to n, which is equal to 5. Now suppose in the same list we have to find 110 in the list. Since the element is not present in the list, even then we have to make 5 comparisons to search the element. So we can say that C worst n is equal to n, which is equal to 5. Here I have explained some asymptotic notations for calculating the runtime complexity of an algorithm. First is big O notation, second is omega notation, third is theta notation. Big O notation. The big O notation is used to measure the worst case time complexity or the longest amount of time taken by an algorithm to complete. Omega notation. The omega notation is used to measure the best case time complexity or the best amount of time or the shortest amount of time an algorithm takes to complete. Theta notation. The theta notation is used to measure the average case time complexity of an algorithm to complete. Here is a list of some common asymptotic notations. These are as below. Please note down these notations for future references. Here I have designed a graph for calculating time and space complexity required with respect to size of program, that is n. Here I have discussed an example for calculating time complexity for linear search algorithm. In this linear search algorithm, best case complexity is if the item is found at the beginning. So one comparison is required, hence best case complexity will be equal to 1. Now worst case complexity, if the item is found at the end then of an array, then n comparisons are required, so worst case complexity will be equal to n. And in terms of average case complexity, item may be found at index 0 or 1 or 2 or n minus 1. Therefore, average number of comparisons required is 1 plus 2 plus dash 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 plus n divided by n, which is equal to n plus 1 divided by 2. Hence, average case complexity is equal to n plus 1 divided by 2. Here I have written worst case, average case and best case time complexity for some common sorting algorithms like selection sort, insertion sort, merge sort, quick sort. Please remember these complexity for future references. स्टूडेंट्स, उम्मीद है आपको मेरा लेक्चर पसंद आया होगा। अगर पसंद आया है तो लाइक करें, शेयर करें, बेल आइकन को प्रेस करें और चैनल को सब्सक्राइब करना ना भूलें। थैंक्स फॉर वॉचिंग गाइस, थैंक यू।